Hello everyone, and welcome to the SQL Fundamentals section of the course. This section is going to focus on SQL syntax. And what's really important about what you're going to learn here is that the syntax in this section can be applied to any major type of SQL database. Let's go ahead and get started. Welcome everyone to this lecture on the select statement. Select is the most common statement used in SQL, and it fundamentally allows us to retrieve information from a table that exists within a database. Later on, we're going to be learning about how to combine the select statement with other statements to perform more complex queries. So what's the actual example syntax for a select statement? Well, after opening up the query editor, what we're going to write for our most basic select statement is select column name from table name. And you'll notice that in general, we capitalize the SQL keywords. This actually isn't 100% necessary. SQL will still run even if you don't capitalize these. But it makes it much easier to read what are the fundamental SQL syntax statements versus what are the column names or table names that you're yourself editing, depending on what you actually want. So the most basic syntax here is we choose a column name from a table. So let's see how this actually works within PostgreSQL. So we already know that we have a database, and then we right-click on that database and we open up that query editor. In our case, it will be the example DVD rental database. And so the way PostgreSQL operates is inside of this database, you're going to have some number of tables. Here we have an example of 3 tables. And recall then each of these tables is essentially like a spreadsheet. We have columns and then rows of data. And here I've just made up some data. So each of these tables has columns 1, 2, and 3, so C1, C2, C3, and then rows of made up information. When we actually say select column name from table name, PostgreSQL essentially reads this a little bit backwards. It first has to decide what table you're referencing. It already knows what database you're referencing because that's how you open the query editor on that database. So it takes a look at what table name you're looking at, and then it's going to take a look at the corresponding column name. So, for example, we could say select C1 from table 1, and it would look something like this. It's actually grabbing column 1, and it'll return back that entire column, and X, Y, and Z. If we want to select multiple columns from a table, we can say column 1, comma, column 2, etc. You just separate out the column names by a comma. And keep in mind, these don't need to be in order. So if you only wanted column 1 and column 3, you would just say select the names of your columns separated by commas, and then from the table you want them in. If you actually want all the columns from a table, you can use an asterisk symbol in order to request all the columns from a table, essentially just asking for the entire table back. So you'll say select an asterisk and then from table. In general, it's not good practice to use an asterisk unless you actually want every single thing in that table. And what's going to happen here is if you use the asterisk in the select statement, it's going to automatically query everything, which increases traffic between the database server and the application, which can slow down the retrieval of results. So you should really only be using that syntax if you actually want the entire table back with all the columns in it. If you only need certain columns, do your best to only query for those columns. Let's go ahead and walk through some examples in our DVD rental database to get some practice with these basic select statements. I'm going to open up pgadmin. Alright, so I've opened up pgadmin. I'm going to click down on servers. Note that I have different versions of PostgreSQL installed on this computer. Go ahead and choose the one that you installed for your computer. I'll go ahead and choose PostgreSQL 12 since that's what we'll restore DVD rental on. I've now connected to that server under PostgreSQL 12, and now I want to query the particular database inside that server. So that's going to be DVD rental. I right click, and then I'm going to open up the query tool. I take a look at the query tool, and I have the query editor as well as the data output. So let's practice our very first query to this database. So if you're ever curious of what tables are actually available to you in your database, what you can do is underneath DVD rental, you can open up schemas. You'll see there's a public schema, keep going down, and you'll see there's tables here. And you can expand on tables, and I'll show you the various tables available to you inside of this database. And you can check out the resources for this lecture or the previous lectures. We actually have a mapping of those tables and the relationships between them. We'll talk a lot more about joining tables together and also programmatically asking a database what tables are within it. But right now, we'll just do this through the pgadmin graphical interface. So I can see there's 15 tables here. And if we click on one of these tables, we can later on see what columns are available, etc. So let's go ahead and start by asking for an entire table back, or all the columns in a table. I say select, and then I type in an asterisk there, from, and then we'll say actor, semicolon. And then I'll go ahead and run this. And if you're on Windows, you can choose F5 to quickly run that. And you'll notice that it has the data output. I'm going to kind of move this over so we can see this. And we can see here it has the actor ID, the first name, the last name, and then the last update. And we can scroll down here and see the various results. So again, this returns back all the columns. If I only want a single column, let's say I only wanted the first name, then I just look at the column name, which is first underscore name, say first underscore name, and then I'll go ahead and run that. And now I only get back the first name. If I want the first and last name, I would take a look at those column names, which I can always refer to over here on the side. Last name's available there, and then run that. Okay. So I can see first name and last name, and keep in mind, they actually don't need to be in any sort of order. If I wanted the last name to show up first, I could say last name, comma, first name, run that, and it would show me in the order I requested. The last name column showing up first, and then the first name. Everything's linked here by what row. So we can see Penelope Guinness, Nick Wahlberg, etc. Now a few more points I want to show you is that you notice that I capitalized the SQL syntax keywords, but even if these were all lowercase, select, and then I put from in all lowercase, and I run this, it will actually still work. It's the same thing. However, it's much easier to read, and it's just standardized notation if we just do this in all caps, and then I can quickly realize if I'm coming back to this, that select and from are the keywords. And notice pgadmin also highlights them for us. You'll also notice that I have a semicolon here. The semicolon is to denote the end of a query, but if you delete that semicolon and still run this, you'll notice it works just fine. So things like capitalizing those SQL keywords, as well as adding in that semicolon, really helps as far as readability is concerned, especially if you're going to be sharing these SQL queries of someone else. It can read very clearly where this actual query is meant to end, as well as what commands you're actually using. You can use the scratch pad here if you want to kind of play around with things later on as our SQL queries get more complex. You may want to work a little bit on the scratch pad. And I'm going to zoom out just so we can see this clearly. There is a query history that you can click here, and you can see the various query histories. And then you can always copy them, or you can copy them directly to the query editor. So for example, if we come back here, maybe to select first name from actor, I could say copy to query editor, and it jumps back to the query editor, and I can see select first name from actor is already there for me. All right. And then if I wanted to, I could run this and edit it in any way I want. So I can just double click here and start editing for another table. Maybe I want all the columns from another table. Let's say select everything from city, semicolon, hit F5, which is essentially a refresh or running this. And we can see here city ID, city, country ID, last update. Okay, so those are the very basics of the select statements. Coming up next, we're going to have just a few challenges to make sure you understood all this. I'll see you at the next lecture. Welcome back, everyone, to this lecture on Select Distinct. Sometimes a table contains a column that has duplicate values, and you may find yourself in a situation where you only want to list the unique or distinct values in that column. The distinct keyword can be used to return only the distinct values in a column. The distinct keyword operates on a column, so that means the syntax looks like this. We say select, and then distinct right in front of whatever column we're interested in grabbing the unique or distinct values from. And then we'll specify what table this column is in. Sometimes to clarify which column distinct is being applied to, you could also add in parentheses for clarity. So note that distinct on a column works with or without parentheses. This is what it would look like with parentheses. And again, it will work without parentheses as well. Later on, when we learn about adding more calls, such as a count call and a distinct call together, some sort of parenthesis structure will actually be necessary to clarify what is actually being called on what. But we're going to see that in a future lecture. Let's first think about what does it actually mean to call distinct on a column. Imagine a table of people who were surveyed to choose a color. So here we have the names of the person, just their first name, and then the color choice they made. Let's imagine we actually called select distinct from the name column from the color table. We'll notice that we have two instances of David inside this name column, which means when we actually select the distinct names from this table, it's going to return back the following, just the unique first names in this actual column. Keep in mind that given the previous example, we don't really know if the person of the name David was a duplicate entry who happened to change their color choice later on as the same person, or if it was two different people that happened to have the same first name. Calling distinct on this particular column just answer the question, what are the unique first names that are there in that table or in that column? It probably makes more sense to ask how many types of unique color choices were there. So what we can do is say select distinct choice from the color table, and here we have all the distinct or unique color options that were chosen. Let's go ahead and see a couple more cases of when distinct would be useful. We're going to jump over to PG Admin. Alright, here I am at the query editor. What I'm going to do is first explore the film table, and there's different ways I can do this. So this is a pretty small database. I could either expand on this film table to see what columns are available, film ID, I could scroll over here, title, description, or I could just say the following, select everything from film. And it's okay to do this since this is basically kind of a toy database and toy table. It's not going to be huge. So we'll go ahead and just run that. And we can see here we have the film ID, the title, description, release year, language ID, and I can keep scrolling to see other information and other columns that are available inside of this film table. So let's think about what kind of questions distinct can help answer. Distinct really helps when we want to know the unique values inside of a column. And if we take a look at these actual tables here, something we may want to know are how many different release years do we have inside of this film database. And what we can do here is say select distinct, and I'll put it in all caps since we're treating it as a SQL keyword. You can see it's highlighted as such. And then we'll call it on release underscore year from film. So if I run this, what's happening here is it's going to return back just 2006. So this quickly answers the question, how many unique release years do we have inside this film table? And it ends up we just have one. All of these films were released in 2006. If we take a look back at this, I should also note that we can add in parentheses. And we can see here that it's directly connected to distinct. And if we run this, we'll get back the exact same result. And for some people, this is more legible, coming back to their old SQL queries. It works either way, so it's really up to you if you want to use parentheses or not. Let's come back and take a look at the entire table again, just so we can check out the columns. You'll notice here we have the release year. Something else that's interesting are the rental rates. And it does look like we had different numeric rental rates. So some movies rent for $4.99, some rent for 99 cents, others rent for $2.99. Distinct can help us answer the question, how many unique rental rates do we have? What we can do then is just say select distinct, and with or without parentheses, we can say on rental rate. We'll go ahead and run this. And here we can see that we have three distinct rental rates, essentially a low tier at 99 cents, $2.99, and $4.99. Later on, we'll be learning how to actually sort these or order them based off a certain value. But right now, PostgreSQL just returns back information as efficiently as possible. So you may actually get these in a different order depending on your operating system. Alright, that's it for the lecture on Select Distinct. Coming up next, we're going to quickly test your new skills by giving you a quick little challenge on Select Distinct. I'll see you there. Welcome everyone to this lecture on the count function. The count function returns the number of input rows that match a specific condition of a query. We can apply count on a specific column or just pass count and then an asterisk. We will soon see this should return the same result because count is merely reporting back the number of rows returned, which is going to be the same regardless of what actual column you're looking at. Let's see a simple example. Here again we have that table with a couple of names and then their color choice. Let's imagine we called select count name from table. Notice here, count does need the parentheses because it's a function acting on something. So it won't work without the parentheses. Keep that in mind. If we were to count the number of names from table, that's just asking for how many rows are there in the name column, which is going to be 4. So the result will be count 4. So again, it's simply returning the number of rows in the table. In fact, this should really be the same regardless of the column we call, because each column has the same number of rows since they're literally in the same table. Which is why, whether you call select count name from table, select count choice from table, or select count asterisk, which is just saying select the count of all the rows for all the columns in the table, they should all return the same thing. Since the original table has 4 rows, that means each column has 4 rows, which is why you usually just see an asterisk from the table. Now keep in mind, it's sometimes useful to use a column name instead of just providing an asterisk, because if you come back on your SQL query sometime later, it may actually help kind of stir the memory of what actual question you are trying to answer. So again, because of this, count by itself simply returns back a count of the number of rows in a table. And count is usually much more useful when combined with other commands, such as the distinct command that we already learned about. Imagine we wanted to know how many unique names are there in the table. So, to answer this question, we need to first decide the distinct number of names. Then we'll provide count on that result of distinct name from table. So the logic that's going to happen is distinct is going to figure out what the distinct names are. Here it sees that David is duplicated, so it's just going to kind of remove that, and now we have the 3 unique names, and then count is going to count the remaining rows here, which in this case is going to be 3 rows. So the end result for select count distinct name from table is 3, answering the question that there are 3 unique names in the table. It won't tell you what those names are. That would just be a distinct call by itself. And again, notice the parentheses structure here. It's informing us that we are calling count on the result of distinct name. If you want, you can also provide parentheses for name on distinct, although that's not necessary as we previously discussed. However, some people find this result more readable. Let's go ahead and explore some examples in pgadmin. Okay, here I am at the query editor in pgadmin. Let's select everything from the payment table just so we can take a look at it. So we'll say select everything from payment, and I can see there's a payment ID, customer ID, staff ID, etc. There's also an amount and a payment date. Let's imagine I just wanted to know the number of rows that are in this table. Now, luckily for us, this table is pretty small, which means I could, if I wanted to, scroll all the way down and then check the actual here on the left-hand column. It's just a count. So I could scroll all the way down and eventually I would see the correct answer. However, and this is actually quite a large table. There's more than 1,000 entries. In a realistic database, you're going to have very, very large tables. So you're not going to be able to just scroll down just to see how many rows there are in this table. So one easy way to do this is just say select count. And then to make it easier to read, I'll pass in the parentheses. And it just is asking count the number of rows in all the columns. So those should all be the same, which means it's going to be 14,596 rows. So much easier to do that than scroll down until you see 14,596. And you could do this for essentially any column. So if I pass in the, let's say, amount column, again, this is just asking how many rows are there in the amount column. Well, it should be the same as the number of rows in the actual table. So notice we get back the exact same result. So when people are beginning to learn about SQL, they sometimes get confused over what column we're going to pass into count, and in the end, it really doesn't matter. It's really probably most common to see an asterisk since, again, it doesn't matter. But sometimes it might be easier to use a column name in order to set your mindset as far as what you were thinking when you were writing this query. So if you come back later in time and you would see this query, you can see that you were probably thinking about the amount column because somebody asked you a specific question of it. So keep that in mind. It might be easier for you to actually clarify with a column name. Okay, now let's go ahead and say, just select the amount column from payment, run this, and I can see there's different amounts that people are paying, $7.99, $1.99, $2.99, $5.99, etc. Let's imagine I wanted to figure out the actual number of payment types. What are the actual number of unique amounts or distinct amounts being paid? If I were to just use distinct on the amount column, I would run this and it shows me the distinct values, $1.99, $10.99, $2.99, etc. Essentially removing any duplicates. So this answers the question, what are the unique payment amounts? However, my question is, how many unique amounts are there? Which means I should be counting the result of this. So one way I could do that is scroll all the way down and realize there's 19 rows here. Or to do this programmatically, I would just say count distinct amount. I run this and notice here, when I'm using these two functions, I will need to specify with parentheses. So I'll say count distinct amounts, and then it actually ends up working. So the reason in this case that I need to use parentheses is because if I don't, PostgreSQL is going to think that I'm trying to call count on some distinct column, which doesn't exist. So this is why I need to call parentheses and specify that distinct amount should happen first before I call count on whatever this result is. And if you want, you can add in another set of parentheses just to make it more readable for you. It really depends on your personal style. And we'll get back the same result. Okay, so that's it for learning about count. Coming up next, we're going to learn about the select where statement, which is really going to help us out in a lot of different query types. I'll see you there. Welcome back, everyone, to this lecture on the select where statement. In part 1, we're just going to be learning the basic syntax structure, and then in part 2, we'll actually jump over to pgadmin and code out some examples. So the select and where statements are really the most fundamental SQL statements, and you're going to find yourself using them in almost every SQL query you do. So the where statement allows us to specify conditions on columns for the rows to be returned. The basic syntax would look something like this. We decide on what columns we want back, so we'll say select column 1, column 2, etc. And then we decide what table we want those columns from, and then after that, we can describe conditions. So we'll say where, and then some manner of conditions. So let's actually go into detail of what those conditions are like. The where clause appears immediately after that from clause of the select statement. And then the conditions are used to filter the rows returned from the select statement. And PostgreSQL provides a variety of standard operators to construct those conditions. And I want to make it clear that the conditions we show here are available in any major SQL engine. So it's not just unique to PostgreSQL. So we first have the comparison operators. And the comparison operators allow us to compare a column value to something, essentially allowing us to answer questions or queries such as, where is the price greater than $3? Or where is the pet's name equal to Sam? So those kind of statements of greater than or equal to or less than, those are the comparison operators. And you're probably familiar with the base syntax operators, at least the operator syntax signs, because they're just basic math. So, for example, if we want to check for equality, we just use the equal sign. Then we also have the greater than and less than sign, the greater than and equal to signs, and then even the not equal to. And there's two ways of doing not equal to in PostgreSQL. You can have a less than and greater than sign right next to each other, or the more common way is to do an exclamation mark and then an equal sign. In addition to those, we have the logical operators, and that allows us to combine multiple comparison operators or effect comparison operators. So you're also probably familiar with these ideas of and, or, and not, and they essentially allow you to use multiple comparison operators. So you can do something like condition 1 has to be true and condition 2 has to be true, or condition 1 is true or condition 2 is true. And then you have the not operator, which essentially means the opposite of whatever condition you're specifying. So where this condition is not true. So let's actually walk through the very basic syntax of what this would look like. And we'll do this with the example table we saw before, where we have some names and some color choices. So in order to get back both columns from the table, we could just say something like select the name, choice columns from table. So now let's try to get only the people named David. So there's a condition there where I want the name column to be equal to the string David. So the way I do this is I say select the name column and the choice column from table where name is equal to David. And note here in PostgreSQL we use single quotes in order to denote these strings. And also when we're checking for equality here, the capitalization does matter. Also keep in mind that I selected both the name and the choice column here. I could, if I wanted to, just select the name column from table where name is equal to David, and then I would just get back the entries on the name column. So it's not terribly useful. So keep in mind you're probably going to ask for more than just the column where you're filtering these conditions on, just as asking for name and choice. Let's imagine I wanted to do multiple conditions. So previously I have two Davids here where we have green and red. I can use those logical operators such as the AND keyword to test for multiple conditions. So here I'm grabbing the name and choice column from this table where the name is equal to David and the choice is equal to red, returning back this single row where both those conditions have to be true. Okay, let's go ahead and see you in the next lecture in part 2 where we jump to pgadmin and work through a bunch of examples available to us inside the DVD rental database. I'll see you there. Welcome back everyone to the Select Where Part 2 lecture where we're going to head straight to pgadmin and code along with a couple of examples just to give you an idea of the different use cases for select, where, as well as comparison operators and logical operators. Alright, let's begin by exploring the customer table. I'm going to just select everything from the customer table so we can explore it quickly. We'll say select and then asterisk from customer, semicolon, go ahead and run this. And I can see there's a customer ID column, a store ID, first name, last name, email, an address ID, some active Boolean, whether or not that customer is active or not, so true or false, the date they were created, last update, and then also an integer corresponding to the active Boolean, so ones and zeros for the trues and falses here. Okay, so what can we do here to start filtering out customer information? Well, maybe something I want to know is who has the first name Jared? Maybe someone comes to the store and asks me, I'm looking for some customer named Jared. So I can say select all the columns from customer. We'll go ahead and delete that semicolon. And then we'll say where, and this is where we have a condition. So we have to say the column name. In our case, it's first name. So we'll scroll over here. You can see we have first underscore name. So we'll say where first underscore name is equal to, and then single quote, capital J, and then Jared. Note how the single quotes are essentially automatically ended for you in PostgreSQL and pgadmin. Semicolon optional if you want to end this or not. We'll go ahead and run this, and now I can see I have that information for Jared. Now let's go ahead and explore the film table to see how we can combine conditions with logical operators. So we'll say select everything from film, run that. And it looks like I have different film IDs that are unique to each film, a title for each film, a description, a release year, a language ID, rental duration, rental rate, length, etc. So let's start playing around with this. Let's go ahead and find maybe all the rental rates that are higher than $4. Recall that when we use distinct, there's really only 3 rental rates, 99 cents, $2.99, and $4.99. So I can say select everything from film where the rental rate is greater than, let's just say 4. Semicolon, go ahead and run that. And now I can see all the results that are back here are now $4.99, $4.99, etc. So they're all greater than $4. And let's go ahead and add another condition on this. So we can do this for logical operator. Let's go ahead and choose ones that are expensive to replace. Notice we also have a replacement cost. Let's go ahead and choose the ones that have a replacement cost greater than or equal to $19.99. So we'll say and notice I don't need to rewrite where again. So the where just applies to all these conditions that I can keep linking together with logical operators. So well, rental rate is greater than 4 and let's say replacement cost is greater than or equal to $19.99. And because these are numeric types, I can directly compare them to these numbers. Note how PostgreSQL lets you know what data type it is. So there's different colors depending if I'm working with strings, whether these are keywords in PostgreSQL or whether they're numerics. We'll go ahead and run this. And now I can see here that we have $4.99 and then the more expensive movies to replace, $19.99, $28.99, etc. And I can keep tacking on more and more. So maybe I want only certain ratings. Maybe I only want the R movies. So you can always remove that semicolon and continue on another line where we say and then maybe rating is equal to, and in single quotes, R. Go ahead and run that. And now we keep filtering more and more on this, etc. And recall that here we're just asking for all the columns, but I can always just ask for only certain columns. So I can say select the title from film. And then we run this, and essentially I get a list of all the titles where these three conditions happen to be true, where the rental rate's more than 4, the replacement cost is greater than or equal to $19.99, and the rating is equal to R. Let's imagine I want to answer the question of how many titles there are where these conditions all happen to be true. Well, what I can do is simply add in a count. So I can either count title, which is essentially counting how many rows are returned here. So if I run this, it gives me back that there's 34 movies where all these conditions happen to be true. But if you remember from the count lecture, I can really pass in any column to this. Or in fact, I can just write an asterisk here, which essentially just count the number of rows that are returned from the film table that satisfy these conditions. And if I run this, I'll always get back the same number. So recall from that count lecture, it doesn't really matter what actual column I apply here because I'm really just asking the question here, how many rows are returned that satisfy these particular conditions? Let's go ahead and explore a quick example of the OR logical operator. Maybe I only want movies that have an R rating or a PG-13 rating. Well, what I can do for that is I can say where rating is equal to R, or make sure we spell this right, rating is equal to PG-13. Notice here I'm still counting the number of movies returned here. I run this and there's 418 movies that satisfy either the R condition or PG-13. Now remember, we also have the not equal to operator in case I want everything that isn't an R movie, for example. I could say something like the following. I could say where the rating is not equal to R. And let's just go ahead and grab all the columns here so we can see the results. We'll go ahead and run this. And if I scroll over to the right, you'll notice on the rating that everything here is everything that's not R. So it's G, PG, PG-13, NC-17, etc. So we have all the ratings here, but none of these are actually going to then be R. All right, so that's it for these code-along examples. Coming up next, we're going to check your understanding by giving you a couple of challenges with these select where statements. Hopefully you can already tell this is a very powerful tool and something you'll be using quite often when it comes to your SQL queries. I'll see you in the next lecture. Welcome back, everyone, to this lecture on order by. You may have noticed that PostgreSQL sometimes returns the same request query results in a different order, meaning you may have run the exact same query on your computer and saw the results in a slightly different order than what I have on my computer. So, in order to alleviate this issue if we want the results in a certain order, we can use the order by to sort rows based on a column value in either ascending or descending order. So that would be alphabetical for string-based columns or numerical order for numeric columns. The basic syntax for an order by statement would be as follows. We select whatever columns we want from the table, and then we decide to order by a specific column. And then optionally, you can add in ASC or DESC, whether you want that ordering or sorting to be ascending or descending. Notice the order by towards the end of the query, since we want to do any selection and filtering first before finally sorting. So that means order by is going to be towards the bottom of a query and one of the very last things that SQL actually performs. So we're going to do all our selection, all our filtering. If we use a where statement, that should come before the order by, and then right at the end, we'll go ahead and do any sorting. And you use ASC to sort in ascending order, DESC to sort in descending order. If you leave it blank, order by just uses ascending by default. Now what's also interesting is you can use order by on multiple columns. So this makes sense when one column has duplicate entries. Let's take a look at this example database or example table really, we have 3 columns here: company, name, and the sales for that individual at that company. Notice here that we have duplicate entries under company. So if we were to actually order by 2 columns here, we could select the company column, the name column, and the sales column in that order from this table, and then we order by company and then order by sales. What does that actually mean? Well, it means we sort everything first based off the company column. So notice we have Apple coming in first in alphabetical order, then Google, and then Xerox. And then the corresponding names also get lined up. However, we can then also order by the sales. So after you've done the sorting based off the company column, which makes sense because there's duplicate values there, within that particular company, we do a second ordering, which is by the sales column. So note the sales now is in an ascending order for each individual within the same company. So we see Andrew with 100, and then Zach with 300. And then for Google, we see Claire with 200, and then David with 500. So if you have duplicate values in a particular column, and you want to sort not just by that particular column, but another column as well, it makes sense to do an order by with multiple columns. And it's going to sort based off the order you provide. So it'll order by company first, and then by sales. Let's go ahead and explore some more examples in PG Admin on the DVD rental database. Okay, here I am inside of PG Admin. What I'm going to do is explore the customer table. So we will say select, and let's select just everything from the customer table so we can take a quick look at what the results look like here. So notice we have this customer ID, and more or less it seems to be in order except for this first one, which is 524, and then we also have the first name and last name. Let's see if we can order everything based off the first name of the user. So that would be an alphabetical order based off first name. So what we do here is towards the bottom we'll say order by, and then we decide on the column. So we'll say order by first name. If I don't leave anything here and just run this, it'll automatically order it here in ascending order. So starting at A all the way down. So then if you start going more and more down, you'll eventually see B's and then C's. This is the same as if I had clarified ascending order. So you may be wondering why bother clarifying ascending order there. Well, it's nice because if you come back to read this or someone else is reading your code, you can realize that they specifically wanted it in ascending order. We can do the same for descending order by adding in DESC towards the end of this order by statement. And now notice we're starting at Zachary, then Yvonne, Yolanda, and going down. So we're starting at Z and then going down all the way to A. Now notice here that we have different store IDs and we also have duplicate store IDs. So we have store ID 1, store ID 2, and store ID shows up multiple times. So we have multiple entries for store ID, which basically means that this particular customer, let's say Zachary Height, goes to store ID number 1. And this second customer, Yvonne Watkins, goes to store ID number 2. So there's Yolanda, Wilma, etc. What we could do is first order by the store ID to get all the results per store and then organize it by first name. So the way this would work is I would say first order by store ID. And if I just run this by itself, notice now I get store ID 1 first. And then if I were to continue scrolling here, it's maybe a couple thousand, so it might be hard to actually see this. But then I eventually get store ID number 2. And then within this, you'll notice that if we scroll back up here, I'm actually just going to select store ID, first name, and last name columns. So let's reduce this a little bit. We'll say select the store ID column, select the first name column, and select the last name column. Run this. So if we take a look at this, the store ID is now sorted starting at 1, and then eventually scroll down, you'll see store number 2. But the actual entries themselves are in no particular order within store ID. So what I could do is say first order by store ID, which makes sense because there's duplicate values in that particular column, and then go ahead and order by first name. So after you order by the store ID, go ahead and order by first name, run that, and here we can now see store ID number 1, then everything starting in alphabetical order based off the first name, and then we scroll down here to eventually hit store ID number 2, and we can see within store ID number 2, all the first names are now in alphabetical order, starting with A. And if you want, you can always add in ascending and descending to each particular order by statement. So I could say order the store ID on descending while ordering based off first name on ascending. And notice here, it's semicolon is optional. So we run this, and now at the very top, we're starting at store ID number 2, and then seeing the alphabetical order, Aaron, etc. And then eventually, if I scroll down far enough, I would see store ID number 1. The other thing to note here is that if I select just first name and last name and run this, it will still work, which means I can technically sort by columns that I do not actually request in my select statement. Now, whether or not you actually want to do that in a real world setting is really up to you. Typically, it would make sense to actually select the column you're ordering by because that just logically looks better as a result, and it'll kind of continue the logic of your SQL query into your results, and you'll understand whatever the person was trying to explore from a business standpoint. But I do want you to be aware of the fact that you can technically order by a column and not select it in your select statement if for some reason you want to do that. Okay, that's it for the order by lecture. Coming up next, we're going to quickly discuss a limit function, which allows us to actually limit the amount of rows that are returned in a query, and then we'll give you some challenges for the order by statement in conjunction with the limit statement. I'll see you at the next lecture. Welcome back, everyone, to this lecture discussion on the limit keyword. The limit command allows us to limit the number of rows returned for a query. It's useful for not wanting to return every single row in a table, but only view maybe the top few rows to get an idea of the table layout. Limit also becomes extremely useful in combination with the order by statement that we just learned about. Limit goes at the very bottom end of a query request and is the last command to be executed, because essentially what the limit does is after you're done filtering with the where statement, ordering with order by, and sorting, and any other sort of conditions or any filters you want to do in a query, the limit is just going to say, all right, how many rows do you want at the end of the day? So let's learn the basic syntax of limit through some examples. This should be pretty straightforward, and you should really be thinking about this in conjunction with order by in order to answer certain business questions. Let's jump over to pgadmin. Okay, here we are in pgadmin. Let's go ahead and explore this payment table again. First, what we could do is just select everything from the payment table. So I can say select everything from payment, and I get this variety of payment IDs, customer IDs, staff ID, rental ID, etc. And then I also get a payment date, which is a timestamp without a time zone, essentially just a day, and then the hour, minute, and then second and milliseconds where this payment actually occurred. What we could do is order by this payment date in order to see either the oldest payments or the most recent payments. So what I could do is say select everything from payment and then say order by payment date. And if we run this on a timestamp, what's going to happen if we refresh this? Notice we get 2007-02-14. So this is in American formatting, meaning it's year, month, and then day. And if I want, I can either order this by default ascending to get 2007 to and then 14, or I could say descending, run this, and I see 2007-5-14, essentially 14th of May instead of 14th of February. So what this actually means is I can use order by in conjunction with limit to get the top n rows of something. So for example, I can answer the business question, what were the 10 most recent purchases in the payment table? So after I conduct my order by, I call in the limit keyword and then provide how many rows do I actually want. So if I just say 5, you'll notice here that right now it's returning everything if I scroll down here. If I say 5, run this, I keep scrolling down, but I only get 5 rows. So essentially what this answers is what were the 5 most recent rows or payments based off the payment date. So we can see the payment date here, and right now we're returning the 5 most recent payments. So this will allow you to get the top n of anything based off some column. So what we do here is just order by some column and then limit it to the top n results that we want. And it's up to you whether you want to do ascending or descending, depending on the actual data type that we're looking at. So we can see here, in fact, some of these payment amounts were zeros. So what I could end up doing is also filtering it where the amount isn't 0. So we can start to get really nice complex queries here. So I can say select everything from the payment table, saying select all the columns from this payment table. And then right here, we're limiting it to the top 5 most recent ones based off payment date in descending order. So starting from most recent, descending to the historical data. And I could also then say where amount is not equal to 0. So we run this, and now I can see the 5 most recent payments where there was actually a monetary transaction and it wasn't just a $0 amount. So this is where we start to see much more realistic SQL queries. Given just the few commands we know, we can already answer lots of business questions. We can, in this case, select everything from the most 5 recent payments where the amount wasn't 0. All right. So hopefully that gives you an idea of the power of limit. And sometimes if you want, you can simply do something like select everything from payment limit 1 to just quickly get an idea of what this table actually looks like. This would show you what data types there are, such as integers, small integers, timestamps, etc., and an example of what these actually look like. So some people like to quickly run this sort of command in order to just see the general layout of a table. Okay, so that's it for this lecture on limit. It's a pretty straightforward thing. Limit just comes at the end, and you can limit the number of rows returned. Very useful in conjunction of order by. So let's test your skills in the next lecture where we talk about some order by challenges. I'll see you there. Welcome back everyone to this lecture on the between keyword operator. The between operator can be used to match a value against a range of values. So for example, we can ask where is a value between a low and a high? And this is essentially going to be a condition you can tag along with a where statement. You should note that using the between operator is essentially the same as asking individually where a value is greater than or equal to low and a value is less than or equal to high. So note that the low and the high here are both inclusive. So it's actually including the endpoints there. You can also combine the between keyword with the not logical operator, essentially asking where is the value not between low and high. And this is the same as asking value less than low or value greater than high. Note here that we are exclusive of the actual low point and high point. So what I mean by that is for the not between statement, if you're saying something like value not between 8 and 9, if a value happens to be 8, it's not going to be included in the not between. Versus, if we take a look back at the between statement, that is inclusive, meaning if you wanted a value between 8 and 9, it would actually include 8s and 9s there. So keep that in mind. And if you want to change exclusivity versus inclusivity, you can just go back and use the AND operator and then specify less than or equal to manually yourself with the comparison operators. Now, the between operator can also be used with dates. You should note that you need to format dates, in this case, in the ISO 8601 standard format, which is essentially just 4 numbers for the year, a dash, then 2 numbers for the month, a dash, and then 2 numbers for the date, or the actual day. So that means it would look something like, where is the date between, and then as a string with single quotes in that particular format, year, dash, month, dash, day, and then the other date. Something to keep in mind is when using the between operator with dates that also include timestamp information, so not just the actual day, but also the hour, minutes, and seconds, you should pay careful attention to using the between operator, especially since we have that issue of inclusivity versus exclusivity of the not between. So you should take into account the fact that a date time, that is both the date and the actual time information, would start at 0-100 hours. So that may have an effect depending on what the actual situation is and whether you want inclusivity or exclusivity around that midnight time or 0-100 hour time. Later on, we're going to study more specific methods to actually work with date time information types. So don't worry about it too much right now. It's just something to keep in mind for the future. Let's go ahead and get some quick practice with the between operator in pgadmin. Okay, here we are at pgadmin. What I'm first going to do is check out the payment table, since that's what we're going to be working with. For our examples, we'll say select from payment table. We'll grab everything, but just limit it to just a few rows so we can see the general syntax here and general columns. So the payment ID, customer ID, staff ID, rental ID, and then the amount and the payment date. So we're going to be working with these 2 columns here. Let's go ahead and see if we can use between on the amount column. Let's imagine we wanted to know the actual number of payments that were done between $8 and $9. So what we can do is say select from payments where amount between 8 and 9. If I just run this, it'll give me all the results. We can see everything here is $8.99. And if I actually wanted to know the total number of transactions, I can just count the number of rows returned, and it's 439 rows. If I wanted to know the opposite, essentially everything that wasn't between $8 and $9, I can simply add not between 8 and 9. I can run this, and then I get the number of payments that were not between $8 and $9. Let's take a look again now at the payment date column. So what we can do is, let's imagine I wanted all the payments that happened on the first half of February of 2007. What I could do is, let's just select everything so we can get an idea of what's happening here. Then we'll say where the payment date column is between, and what we're going to do here is make sure we format this correctly, which is going to be the year dash the month dash, let's say 01, and we'll say 2007 dash 02, and then the 15th. So we run this here, and we can see all these payments happen between the 1st of February 2007 and the 15th of February 2007. Now, something to keep in mind, especially when you're dealing with timestamp information, is that this timestamp information includes both the date and hour, minutes, etc. So that means PostgreSQL essentially has to decide, does a day start at 0 hours or at 2400 hours? And if you're dealing with exclusivity versus inclusivity, that actually might affect your logic. So what I mean by that is take a look at the results here. They all actually happened on the 14th. So if you kind of scroll down, you'll see there's 27 rows, and essentially all the payments that happen between the 1st and the 15th all happened on the 14th. Now let's actually switch this to be all the payment dates from the 1st to the 14th. And this is where students often get confused. They would actually expect to see these results. But if I run this, you'll notice nothing gets returned. And that's because when we're dealing with this end date, it's actually only going up to the 0 hour mark. It's not going to the end, which would be the 2400 hour mark of the 14th, which is why for these sort of between statements, when you're dealing with timestamp information, you just have to be careful of that. So you always want to double check and make sure you're getting the results you expected. So in this case, I'd have to go all the way to the 15th to actually include information that happened on the day of the 14th. Okay. And later on, we're going to learn a lot more about how to deal with timestamp information such as this. So that's it for the between examples. Coming up next, we're going to learn about a couple more SQL keywords that are very helpful in different types of queries. I'll see you there. Welcome back, everyone, to this lecture on the in operator. In certain cases, you want to check for multiple possible value options. For example, if a user's name shows up in a list of known names. So instead of having to write a bunch of or statements, such as name is equal to David, or name is equal to Claire, or name is equal to Zach, we could use the in operator to just create a condition that quickly checks to see if a value is included in a list of multiple options. So you can check something like, where name in Zach, David, and Claire. So the general syntax will be something like this, value in, and then a bunch of options. So, for example, an example query could be select the color column from table where color in red, blue. So note here that the options are in this little list in parentheses, and then we use the in operator to basically specify that we're checking for the color condition that happens to be either red or blue. So these are a bunch of or statements. So anything red and anything blue will be returned to us. And we can always expand this to more options quickly. So we can say, now where the color is red or blue or green. So essentially there's a little or statement in between all of these. Keep in mind you can also combine this with the not operator to essentially do this excluding these values. So where color is not in red or blue. It's essentially every color that is not red or blue. Let's go ahead and quickly see some examples in pgadmin. Here at the query editor, I'm going to take a look at the payment column or a payment table. Well, let's just select everything from payments. Let's just limit this to 2 rows so we can take a look at the result here. And notice we have an amount column. Let's first figure out what are the actual distinct values that are available to me in the amount column. So what are the unique amounts that we're charging? So we can say distinct amount from payment, and I'm not going to limit this since I want everything back. I run this and I can see I have $10.99, $1.99, etc. And what I could also do, just for clarity, is order this by amount, as we've seen before, and now I can order amount 0, 99, etc. So maybe I want to figure out all the orders that happen to be 99 cents, 198, and 199. So how could I do that? Well, what I could do is I could select any columns I want or everything from payment, and then we'll say where the amount is in, and here we'll go ahead and specify 99 cents, 198, 199. Note here that I'm not using strings or quotes because this is a numeric data type. So if we go ahead and run this, we get back a bunch of values where the amounts happen to be in 199.99 cents or later on 198. And if I wanted to figure out how many payments actually occurred that happened to be one of these three values, I could run this and I get back that there were 3,301 payments. Now let's imagine I wanted the actual opposite information. I wanted to count out how many payments were not 99 cents, $1.98, or $1.99. Well, there's a couple things I have to do here. First, notice here again I have the parentheses of that list of options. If I just add not in front of this and run this, then I get back the amount that is not in 99 cents, 198, and 199. So there's 11,295 payments that are not these three values. And let's go ahead and explore this on a string column to finish this off. We'll just say select everything from customer. Take a quick look at this. I have the first name and last name. So let's go ahead and select all the columns from customer where the first name is in, and let's just give some options like John, Jake, and Julie. We'll go ahead and run this. And here I can see there was no one named Jake in this particular table, but we did have a Julie and we did have a John. Okay. So that's the way the in operator works. Main things to keep in mind is that you're using parentheses here and then commas to separate out your options. And your options should be matching the general syntax of the column. So we want to make sure that for numerics, we're providing numerics in the list. And for strings, we're providing these single quote strings here. And we can always say not in if we wanted to see essentially the exact opposite. All right. That's it for this lecture. I'll see you at the next one. Welcome everyone to this section on group by. In this section, we're going to be discussing group by and aggregate functions. Group by is a SQL statement that will allow us to aggregate data and apply functions to better understand how data is distributed per category. In this section, we're first going to begin by discussing aggregate functions without any group by applications. Then we'll learn about group by. With part 1, we'll just discuss the theory behind it. And then in part 2, we'll actually show you some implementation of group by statements in pgadmin with pgsql. Now we'll discuss the having call, which is going to allow for filtering in conjunction with a group by statement. Let's get started. I'll see you at the next lecture. Welcome back, everyone. Before we discuss group by operations, we should understand aggregate functions in general. SQL provides a variety of aggregate functions, and PostgreSQL is no exception to that. And all the functions we see here are available in any major SQL engine. The main idea behind an aggregate function is to take multiple inputs and return a single output. Now, PostgreSQL provides many different types of aggregate functions, but we're just going to discuss the most common aggregation functions in this particular lecture. The most common aggregate functions are average, which returns the average value or mean value. There's count, which we're actually already familiar with, returns the number of values or rows returned. Then there's max and min, which return maximum and minimum respectively. And then there's sum, which returns the sum of all the values. So it adds everything up in that particular column. Keep in mind that aggregate function calls happen only in the select clause or the having clause. We don't know about the having clause quite yet, but we're going to learn about it later on in this section. Some special notes to keep in mind for certain particular aggregate functions is the average call returns a floating point value many decimal places long. So for example, it could be something like 2.342418, etc. And you can use the round function on top of average to specify precision after the decimal. So we'll see that in this particular lecture. And keep in mind that count simply returns the number of rows, which means by convention we could just use count asterisk in order to see the number of rows. We can either pass in a specific column or just an asterisk, since it's essentially the same thing. But we've already discussed that before. Let's go ahead and see some examples of aggregate functions in our own database. And head over to pgadmin now. All right, let's begin by exploring the film table, since we'll be using that. So we'll say select everything from film. And if we run this, we can see we have a film ID, title, description, and then release year, language ID, and we also have this replacement cost. Notice we have several values here. Let's imagine right off the bat, I wanted to know what the minimum replacement cost was. Well, what I could do is call my aggregate function, and then I'm going to call parentheses, since this is a function call, and I call it on that column, replacement cost. And when I run this, it's going to return back the minimum replacement cost. So at a minimum, we're going to have to spend $9.99 to replace a certain film. Now that also means certain films are more expensive. So maybe we have a budgeting question asking what's the most we can expect to pay to replace a film. In that case, we can just call max and figure out the maximum replacement cost. So the maximum replacement cost now reported back is $29.99. So that is the min and max function, pretty self-explanatory, and you can call them just on any column here. Keep in mind, if we were to try to call something else, like let's say I also wanted to call a film ID column for some reason, that doesn't really make sense. And the reason for that is we're just actually calling an aggregate function on a column, which means max replacement cost just returns a single value. So it doesn't really make sense to call another column with this. In order to call other columns, we'll have to learn about the group by statement, which is coming up next. So keep that in mind. When you're doing just simple calls or queries like this, where we want to figure out the min or max, it doesn't really make sense to call other columns there, since we're aggregating a bunch of values to just a single value. What you could do is something like min replacement cost from film, and we run this, and that works. And the reason this works is because that function, maximum, and this function, minimum, are both returning a singular value. So this will be the max and min for your replacement costs. So keep in mind, because those rows happen to match up, that sort of query makes sense. Okay, let's explore the other aggregate functions we talked about. We're already familiar with count, which essentially is counting the number of rows returned. So we can say select count in asterisk, run that, and that returns back how many rows we have. So we have 1,000 films. And keep in mind, this works on any column. So we could also say film ID, and that's essentially the same thing. Since that's the case, by convention, we typically just write an asterisk there. And we're already familiar with count. Let's imagine we wanted to know the average replacement cost. What I could do is say average replacement cost, run that, and that's going to grab the mean or average from the film table. However, you probably noticed it looks a little strange here, and that's because by default, this average call gives you a lot of significant digits. So if we expand this column, notice how I'm stretching it out here, we can see that it's actually 19.984 and then a bunch of zeros. So realistically, you probably don't want all of these significant digits past the decimal point. So what we can do is wrap this around with a round function, and the round function actually takes in two parameters. One is the value you actually want to round, and then we're going to put a comma here and how many decimal places we want to round it to. So we'll say to 2 decimal places. And this is essentially a mathematical call on this result. So it's going to take this result and then round it to just 2 places past a decimal. And then when I run this, notice I get back $19.98 as the average replacement cost from the film. And we can always edit this if for some reason we wanted 3 decimal places. We can run that and it keeps going. If I said 4, as you may have guessed, it'll start including the 0. So you can either stretch out this column to see all the results if you don't have that rounding call, or realistically, you're probably going to want to round this to some degree. Again, notice how round uses parentheses in order to organize its parameters or its inputs. Here we have the input that we're trying to round, and then the second parameter is how many decimal places. So we discussed average, count, max, and min, and then we finally have sum, which is going to sum all the values in a column. So what does that actually mean? If we take a look at our table again, select everything from film, let's imagine for some reason we had to replace every single film. So we were opening a duplicate store and had to replace every single film. So we needed to figure out the total sum of the replacement cost column. What we can do is say sum replacement cost. We run this, and it would cost us $19,984 to replace all those movies. And if we think about this value for a second, it actually makes perfect sense. Recall that when we were taking the average replacement cost, it was 19.984. And here, we're replacing 1,000 movies with the average replacement cost, so which means the sum of the replacement cost should equal the average times the actual amount of movies you have. So that's essentially 19.984 times 1,000 movies, which means, again, the total cost to replace all the films would be $19,984. All right. So those are the aggregate functions by themselves. That's average, count, max, min, and sum. You can hit the slides and check out the link for more complex aggregate functions, some of them which we will go over in later lectures. But right now, these are really the most common ones you should know right off the bat. And coming up next, we're going to see how we can use this in conjunction with group by to create very powerful queries. I'll see you at the next lecture. Welcome back, everyone, to part 1 of our lecture series of group by. Group by allows us to aggregate columns per some category. Let's first explore this idea of a simple example, and then we'll go over the SQL syntax. Let's imagine we have the following table. We have some sort of category column. Here we have A's, B's, and C's, and then some data value associated with them, such as 10, 5, 2, etc. We can imagine that maybe the category here stands for some sort of company, and the data value is how much we sold to that company. So we had one deal of $10 for company A. Later on, we had a $5 deal for company A, then a $2 deal for company B, and so on. So when we're actually performing a group by, there's a couple of key things to consider. The first is this category column. We need to choose a categorical column to perform the group by on. That is to say, categorical columns are non-continuous, or at least we're treating them as non-continuous for the sake of the group by. Now, something to keep in mind is these can actually still be numerical, such as cabin class categories on a ship, class 1, 2, 3, and so on. And you should also keep in mind that they actually may appear continuous, but you could treat them as a category. For example, if you recall to our DVD rental database, we have different rental rates available, such as 99 cents, $1.99, $2.99, etc. We could treat each of those rental rates as its own separate class or own separate category. So just because something is being treated as categorical doesn't necessarily mean it's non-numeric. And we're going to see different examples of that in the next lecture when we actually program out in SQL some group by statements. But let's first go through the idea of what a group by actually does and how it relates to aggregate function calls. So the way a group by operates is the following. We have already chosen our categorical column. Then what we're going to do is essentially split this table up on a per category basis. So we have everything that went with category A, then B, then C. And then we have the corresponding data values. Recall that an aggregate function takes in multiple values and reduces them back down to one single value, such as the sum function can take in all these values per category or grouped by category and then return back their sum. So the total sum of sales to category A was 15, 6 to B, and then 18 to C. And we could do this with any of the aggregate functions that we just learned about. For example, we could take the average data value per category, 7.5, 3, and 9. We can even do something like a count per category. In this case, there was 2 rows per category, so they're all the same, 2, 2, and 2. So let's actually explore the general syntax. So the most basic group by call looks like this. We select some sort of category column or something we've deemed to be categorical, and then we choose to perform some aggregate function on the data column. So AGG here is just some placeholder for some aggregate function on some data column. We select it from the table, And then immediately after that, we call group by that category column. So the group by clause must appear right after a from statement or right after a where statement. So if you want, before you do the group by, you can filter things out using a where statement. So here we see just grouping everything together by the category. But if we wanted to, before we actually execute that group by, we could have done a where statement, essentially saying something like where category column is not equal to A, essentially ignoring all the A categories before we went ahead and did the group by. So the thing to keep in mind is the group by either has to come directly after a from statement or directly after a where statement. Now, one of the most important things to realize when learning about group by is the following. In the actual select statement, columns must either have an aggregate function call on them or be themselves in the group by call. So what does that actually mean? This is where beginners often get tripped up in learning about group by, so pay close attention to this one. So if we're using a group by statement, then if we're selecting that particular column just by itself, it must be included in the group by statement. So notice here, I've decided to select the category column, then that particular column must also appear in the group by statement. The only exception to this is if I'm calling some sort of aggregate function on the column itself. So in this case, because I'm aggregating something on the data column, it does not need to be included in the group by statement. So let's imagine a different example. We can have something like select company, division, and then sum of sales. So you can imagine we had 3 columns in this table. One were different companies, and then the divisions within that company, and then different sales per division per company. So what we're doing here is, again, notice that if I'm selecting a column, such as company and division, then they must also appear in the group by statement. So that means we can group by multiple columns, and we essentially just decide the order to group by in a very similar fashion that we decided the ordering of different columns when we learned about the order by statement. So again, here I'm selecting column and division. Since they don't have an aggregate function, they must appear in the group by clause. Notice again, the sales doesn't appear in the group by statement, which means it must have an aggregate function associated with it. So essentially what this is returning is the total sum of sales per division per company. And keep in mind that the where statements should not refer to the aggregation result. So you shouldn't be trying to do any filtering using a where statement on sum of sales in this case. Later on, we are going to learn how to do that using the having statement to filter on those results. But for right now, if you are using a where statement in conjunction with a group by, that where statement shouldn't make a reference to what is being aggregated, such as sum of sales. That is what the having statement is for, that we're going to learn about later. So notice what we're doing here is we're saying select company division sum of sales from finance table, where division is in marketing and transport, essentially filtering out the divisions before we actually perform the group by on the company and division. And again, notice here, company and division appear in the group by. Sales does not because it has the aggregate function associated with it. Here's another example that if you want to sort the results based on the aggregate, you have to make sure to reference the entire function. So in a simpler example here, let's say we wanted to sum the sales, total sales per company. Then we could select company, sum of those sales from the table. We will group by company. And then the other thing to notice here is if I actually wanted to order by the sum of sales, I don't just say order by sales. I have to say order by the sum of sales. So notice that whatever I'm ordering by, that total statement should exist somewhere in that select clause. And then you could add something like limit 5, which would essentially show you kind of the top 5 sales or bottom 5 sales, depending if you did ascending or descending order per company. All right. So I know we just went over a lot of this, and it's best learned through practice. So I'll see you in part 2 in the next lecture, where we actually practice on our own DVD rental database. I'll see you there. Welcome everyone to part 2 of our lecture series on the group by statement. Let's go ahead and jump to our database and work through some group by examples so we can actually build in some practice into creating a query that would work with a group by clause. I'm going to head straight to pgadmin. All right, here I am at pgadmin. First, what I'm going to do is explore the payment table. I'm going to do this just by saying select everything from the payment table. Typically we wouldn't do this, but since we have a small table here, it's not so bad to just explore it. It looks like the payment table, we have a payment ID, so it's a unique identifier per each payment. Then we have a customer ID. So notice here, it's categorical. So even though this is a number, this is essentially the actual customer ID. So this is customer 341, and you can see he's visited multiple times and rented out multiple things. And he had different interactions with different staff. So we also have a staff ID, which is also a numeric, but we can treat it as a class. Since it's a kind of a category here, we can think of this almost as the name of the staff person. In the same way, we can think of customer ID as here we have kind of a named identifier per customer. Then we have the rental ID here, essentially what movie was actually rented. Later on, we'll learn how to join this rental ID column to the actual film column to see what actual film is being rented. And then we have the amount on that particular transaction, as well as the payment date. So let's do the simplest group by possible, which is to group together the actual customer IDs. So what does that actually mean? Well, I could say select customer ID from payment, group by customer ID. So if I run this, this is actually essentially the same thing as selecting the distinct customer IDs. This is a bit of a roundabout way to go about it, but if you think what we're doing here, we're just kind of aggregating all the customer IDs together. And we're not performing any aggregate functions on any other columns, so we just get this list of customer IDs. And if I wanted to, I could add an order by statement here to order by that same column. And essentially, I just get the customer IDs here that we have in the payment table in order. So nothing too crazy here. And this is not a typical use case for a group by, but it's the simplest group by possible of just selecting a column and then grouping by it, which is actually the same as essentially selecting the distinct values of that column. What's probably more helpful is to do this in conjunction with an aggregate function on another column. Let's imagine I wanted to answer the question, what customer is spending the most money in total? Well, what I could do is take the sum of the amount column in conjunction with grouping by customer ID. So if I run this, I can now see the total sum that every customer spent. And then if I wanted to actually order this, I would say order by, and I can't just say order by amount. I have to say order by the sum amount. So that is truly what this column is. It's not just the amount column. It's a total sum of the amount column per customer ID. And a lot of times that the word per really helps beginners understand what the group by is doing. So I can read this as the total sum amount per customer ID. And I'm going to run this, and now I can see this is in order. And we can change it from ascending to descending if we want with ASC or DESC. And this is a very typical SQL query that is using group by to answer a real question. What customer ID is actually spending the most amount of money? And we can do other things like actually count the number of transactions they're having. So I could do something like this. Instead of actually saying, take the sum of the amounts, actually just count how many transactions they're having. So notice here the difference in the question. Sum is asking for the total amount of dollars being transacted. Count is just how many transactions are occurring. So when I run this, I can see the count here with customer ID 148 having 45 total transactions. Okay. Now what we can also do here is use group by on multiple columns. So we discussed this, but let's go ahead and see it in practice. I'm going to first quickly show you the entire table again so we can get an idea of it. So again, we have that payment ID, customer ID. Notice there's also a staff ID. So what I could start to explore is grouping by customer ID and then grouping by staff ID, or grouping by staff ID and then grouping by customer ID. So let's go ahead and show you an example of that. I'm going to say select customer ID, staff ID, and then some amount. And I'm going to group by staff ID and then customer ID. So if I just run this, what's happening here is it's telling me the total amount spent per staff per customer. So that means customer number one spent $60.85 with the staff ID person number one. And what I could do if I wanted to is order by the customer ID. So when I run this, I can now essentially see how much each customer spent with each staff member. So in this case, it looks like customer 1 spent $60.85 with staff ID number 1, and then $53.85 with staff ID number 2. Something to keep in mind here is while the group by order does matter as far as how you're grouping things together, the actual select statement, that order doesn't really matter. So I could, if I wanted to, organize the results by staff ID first, and then by customer ID. So if we just see those results, I'll go ahead and remove the order by just so we can see those raw results here. But here, I'm essentially not changing any information. So we still see staff ID, customer ID, and then the total sum per customer. And then if you wanted to, you could either order by staff ID, run that, and I can see all the ones here. And then we could kind of do a sub-ordering by customer ID. And so I can see staff ID 1, and then there's transactions with 1. Staff ID 1 is transactions with 2, etc. Or I could order by customer ID, run that, and now notice I see customer ID is ordered, but it's ordered and centered here in the middle. So keep that in mind. All of these are essentially showing you the same information, but it's up to you how you actually want to display it. So most often, you're going to actually select things in the same order that you're grouping by in. So keep that in mind. And then ordering by, it's up to you depending on what kind of question you're trying to answer. So we could have also said order by sum on the amount column, run that, and we get back these results. You can order by any of these 3 columns or multiple columns. But the main thing to note here is that I can group by multiple columns. Okay. The last thing I want to point out, and we will learn about this in much more detail later, is when you do a group by on a date column. So if we take a look at select everything from payment, notice that we had a payment date, which was a timestamp. Because it's a timestamp, it not just has the date information, but the time as well. So it has the hour, the minutes, the seconds, etc. So if we actually want to perform a group by a date, we have to call a specialized date function to convert the timestamp to a date, and then we can actually group by that. So what I'm going to show you is that function first. We can say select date from payment date, and we will learn a lot more about dealing with timestamps later on. But if we just run this, we can expand this column, and notice here, it's essentially just filtered out the actual date. It's removed that timestamp information, which makes sense because we don't want to group by every single transaction per minute. What we probably want to do is just group by day. So I'm going to say select the date on the actual payment date timestamp, which is essentially just the day from payment. And then let's go ahead and group by date, payment date. If I run this, this is essentially just returning back the distinct dates, but maybe I want to figure out how much is actually being processed each day. So I could take the sum of the amount column, run that as well, and then maybe I want to order by the actual sum amount column, run that, and I can see the days where we're having the least amount in total dollar transactions, or depending how I sort this, if I sort it in descending order, I can see the dates that we're having the most in dollar transactions. Again, what this date function is doing is it's extracting just the day portion from that timestamp information. Because if you just said group by payment date, the main thing to keep in mind is I don't want to just group by that payment date because it was a timestamp information down to the sub-second, which means I would essentially almost have a unique category per payment, which isn't terribly useful. However, we did have multiple payments on the same day, which is why I'm using date to extract just the actual year, month, and day information from payment date, which then means I can group by that. All right. So we've seen a couple of examples here already with using group by. What I want to do is give you a couple of challenge tasks. And these challenge tasks are probably going to be a bit harder than what you've encountered before because we are making a bit more of a leap in learning about group by as far as what operations and queries we are now capable of. So keep that in mind. These challenges won't be as simple as the ones we saw before, but hopefully they give you a good run for your money. All right. I'll see you at the next lecture where we present the group by challenges. Welcome back, everyone. In this lecture, we're going to discuss the having clause. The having clause allows us to filter after an aggregation has already taken place, so it comes after a group by call. Let's take a look back at one of our previous examples. Let's imagine this very simple query where we're selecting some sort of company column and then taking the sum of the sales column from some financial table where we group by company. So we're aggregating sales per company. Now we've already seen we can filter before executing the group by with a where statement. For example, here I could put a where right before my group by and say where company not equal to Google, because maybe I don't want to include Google in my final results. So that's okay because the company isn't being aggregated in any sort of way. It is in the group by statement. However, it's not having an aggregate function being called on it. So I can use where. But what if we actually wanted to filter based off the sum sales? So keep in mind that since we're calling sum on sales, that's not going to happen until after that group by statement is executed all the way at the bottom, which means we cannot use where to filter based off aggregate results because those happen after the actual where statement is executed. So if after performing the group by and calculating the sum of sales per company, I wanted to then perform an additional filter on that result based off the sum of sales, I could add the having clause. So having allows us to use the aggregate result as a filter along with a group by. So you can essentially think of this as a where statement, but only for something that is being aggregated through the group by. And hopefully you can see that connection quite clearly here. So again, here I'm able to now filter based off the aggregate result of sum of sales in my having clause. So here I'm saying, do the filter of the where, and then after you group by, go ahead and do another filtering where we're having the sum of sales greater than some number like $1,000. All right, let's explore some examples of having in our own database. And then jump to PG Admin now. All right, here I am at PG Admin. I'm going to work through a very similar example that we just made up. Let's first check out our payment table. So we'll select everything from payment, go ahead and run this. And we're already familiar with this. We have the customer ID, staff ID, etc. Let's go ahead and take the total sum amounts for a customer. So we'll say, select the customer ID and then take the sum amount from payments. And we'll group this by customer ID. So we can run this and this all works out fine. I already know that if I, for some reason, wanted to filter out certain customers, I could say something like this, where customer ID, and maybe I wanted to say not equal to, or I could say something like not in some list of IDs. Like, let's go ahead and remove 184, 87, and 477. We run this again, and no problem. You saw that now those no longer exist here in the results. Now, what I cannot do is filter with a where statement on some amount, because the sum of the amount's not going to happen until after I call the group by. So what I'm going to do then, let's go ahead and remove this where example to simplify things. I can say, after the group by, having some amounts, and let's just say greater than 100. So we go ahead and run this, and we can check out the results here. And now you'll notice everything's been filtered, so all the sums are now greater than 100. You should also notice, just like when we were using order by with an aggregate function on a column, we have to actually specify some amount. We don't just say amount. Let's explore using having with a count call instead of just a sum call. We can do this by maybe exploring the customer table. Just to remind you, we'll select everything from customer table. So this is the customer ID, a store ID, first name, last name, their email, address ID, etc. So what we can do here is, let's imagine we wanted to know the number of customers per store. What I could do is, if we scroll over here, grab the store ID and then count the number of customer IDs associated with them after I group by store ID. So we're going to say store ID and then count customer ID from customer after I group by store ID. we run this and I can see the total count of customers per store. Keep in mind, I don't have to actually pass in customer ID because this is just saying how many rows are there per store ID. So I could put an asterisk here, run this again, and you'll notice I get back the exact same results. Now let's imagine I wanted to select only stores that had more than 300 customers. Well, in this case, I'd have to filter based off something that's already been aggregated. So I can't do that with where, but I can do it with having. So I can say having a count asterisk greater than, let's say, 300. And that's essentially performing the filter after the group by. And keep in mind, depending on how you want to think about this, you can switch out an asterisk there for customer ID, and it will perform the exact same. So customer ID, run this, we get back the exact same results. It's up to you which one's easier to read. Here, if you come back to this quite clearly reads as number of customers grouped by store, where the number of customers is more than 300. If we just left an asterisk there, then we'd have to remember that the customer table represents all the customers per store there. Okay, so let's go ahead and test your skills. In the next lecture, we'll give you some challenges with the having clause. I'll see you there.